So this is the second problem with medium difficulty for weekly contest LeetCode 295. Please help to click the like button to support the channel. Let's start with the problem. Basically, we are given a sentence where the sentence is guaranteed to have a single space separated words, where each word can either have digit, lowercase letter, and the dollar sign. A word represents a price if it is non-negative real number preceded by a dollar sign. For example, $100, $6.75 represent prices while these are not representing prices. Other than the sentence itself, we also give a discount, which is we are asked to apply a discount for all those words that is detected to be price. And then we have to return exactly 2 decimal point. We return a string that has been modified. What we modify is the price words into a discounted price. An example is like this. This is the sentence with a discount of 50%, and notice that these are the price. This is not the price because the dollar has to be in the first letter. So the converted sentence become like this. Notice the 2 decimal point behind the comma, and that's it. Okay, well, notice this one doesn't change. So that's the problem and the expected return that we are asked to write the code about. For this problem, actually, there is no tricky stuff here. What is required from us to solve this? So we are not talking the tactic. The tactic is quite simple. There is nothing tricky here. Basically, we just need to translate what is said in this paragraphs into program. Okay, so the key things is how to get a word from a sentence. The keyword is in the single space, and then the second thing of the translation is about what is price. It is a non-negative real number preceded by dollar sign. Then also what is asked about us at the end, which is to apply discount on this and then recreate the sentences with the discounted price. That's it. And then we have to translate it. So that's a tactic, as simple as translate those things into program, into code. Now let's start with the code implementation, which I've been reading it up here. Remember that just now the second part, one of the part that we need to be translating is about the price. Here I'm preparing a subfunction that basically given a word, it will return none if it is not a price. If it will return the price if it is a price. Okay, so what was price again? Price, a non-negative real number preceded by a dollar sign. So that's why preceded by a dollar sign. This is where it does that. Basically, it's checking that the first letter should be dollar. If it is not, it will return in none. Then the rest of it, from index 1 to the rest, become the potential value of the price. And a price will be a real number. A real number here is defined as something consisting of digits or a dot, right? That's why I'm checking here if it is having what you call it, letters, an alphabet letters, we directly return none, because actually during the process, the program, I found there was something like this input. This actually an E notation, but turns out they don't want this to be considered as a float. While in Python, if you write it like this as a string and you do a conversion, it will be treated well. That's why I specifically catering for this alphabet check here, because the program doesn't like it. Okay, so it really depends sometimes that what you know as a mathematical things not really the same things that the problem want to ask, and then you have to go along with it. And then there is a float here. The only thing that I don't have here that is mentioned is about the non-negative stuff. And somehow, when I submit this, it was accepted. But if we want to be strict to the conversions, translation of the description, we should have another check that if file is actually less than 0, we should return none instead of the file itself, because the price only is a price when it is a non-negative value. Okay, so other than that, of course, we return none. That is, if somehow there is another thing that we are not expecting that actually making this float conversion fails, it will raise exception in Python. So that is about getting a price. And then about how to do the things itself. First, we split it up into by a single space here. Then we got all the words, and then we're preparing this price index map. This will store actually the key is the index in this list that we just split it up, and then the value will be the discounted price. We need this index and the discounted price because later on we will replace this when we rebuild the sentence. So we will replace for those specific index with the discounted price that we calculated here. In order to do that, what we do is we explore each word and then we try to get the price of each word. If the price is not none, it means that it is a price, the word is a price, then we store it in the price index map with the key index itself, and the value is the 2-digit behind comma, and then this is the discounted price. The discount was given as a percent, so a 50 discount means 50%. That's why we do this 100 minus discount and divide it by 100 as the formula to get the discounted price. So after we got the prices, the index of it, and the formatted 2-digit behind comma, we do another explorations of the words to build the words converted list. Whereas if the index is in the price index, we will take the value from the map that we used just now. So we will store to the words converted the discounted price string. Otherwise, we just use whatever is in the words. At the end, we will join it with this function. We join it within a single space. And then that's it. Okay, one thing to be noticed, this is the one of the efficient way to actually do a string join in Python. So you have to store it in a list and then join it at the end, because it will be more expensive if you do this, because this will create a new string every time you do this plus sign operation in Python. So that's just a little bit about it. Let's submit this to see whether this is accepted, and it is accepted. Okay. So those are the code implementation. Once again, the tactic for this medium problem somehow is pretty straightforward. Just translate the problem. How about the time complexity analysis? So if we see the get price itself, this is just a check of it per word. If we use the unit as word, actually this is just a big O1. Okay, if our unit is word. If our unit is letters, that's a different thing, it's big O-N. And then this is the split, and then after that, for its split, of course, behind the scene, a split will be big O-N, with N is the number of word, because it need to go through those wording, right? Actually, if you go through all the letters and so forth, it's also the same thing. Maybe we will just use N as the number of letters. Yeah, not really. Number of words, I think. Good enough. And then for each of the enumerations of the words, so actually if N is the number of letters, let's just make N is number of letters. But notice here that yeah, the word says big O-N because if the sentence is one single word, right? And then for I, W in enumerate words. This means this is a subset of it. If all the worst case is of course big O n, because if all the letters is actually all the words is one letter, then it's become big O n. So that's why I'm making letter into the n, because it's the easiest way to actually make a sense of everything. And then the get price we already calculated. Remember, the get price can be big O n, but notice that although the get price is big O n, the extremity of it only comes when everything is one word. When get price reaches the worst case big O n, this is big O1. That's why later on, when we calculate the whole for loop here, it's not n squared. It's just big O n, because the expense, the cost of get price and the for loop here is actually in reverse with each other. Okay. And then if price is not none, then this is where we do conversion, but conversion is just like that, so that's just big O1. Actually, the way we can look here, how about the intermediate? So if somehow half of it comes from the words and half of it comes from the price. What I mean is, about if the words and W, this is still just a big O n, with n is the number of letters. And then words converted. This is enumerations of the words itself, so it's just another big O n. While here is just a check into the hash map, that is big O1, and then appending big O1, another appending big O1, joining. Joining will be a big O n. So if we go through here step by step, everything just big O n. There is no sorting here. So time complexity will be big O n. Okay. So that's about it for this problem. Thank you for listening in. Bye.